So factoring using synthetic division, fully. The key here is we want to fully factor using synthetic division. So we're not going to do all of the factoring using synthetic division. We're going to start with synthetic division and then use our other methods like greatest common factor, though we should do that one first. Maybe grouping, but largely our quadratic factoring today. Eventually, we're going to get to the point where we only factor using synthetic division, or we have the ability to. It's probably not the easiest way every time, but we'll talk about that not this week, but probably next week. Okay. We're going to start today where you're given one of the factors. So also eventually you'll be given no factors and you'll have to come up with what they are from scratch. But given x plus 5 is a factor, fully factor f of x equals x cubed plus 9x squared plus 23x plus 15. On Thursday last week, we were given a polynomial, x plus or minus some number, and we checked if it was a factor using synthetic division. Now we're just told, right, this is a factor. So we should get a 0 at the end of our synthetic division. We should. If we don't, well, then it's not actually a factor and the problem lied to us. So that's not going to happen. So we're going to set up our synthetic division, use the opposite thing here, -5. And then we use the coefficients from the problem. So 1, 9, 23, and 15. And then we're just going to add down and multiply to find our next addition until we're at the very end. And we should get 0 at the end. They already told us that it was a factor, so we should get 0 at the end. There should be no remainder left over. So we're just going to add down. 1 plus 0 is 1, and then multiply that number by -5. So 1 times -5, -5. Add the 9 and the 5, or 9 minus 5. We get 4 times -5 is -20. 23 minus 20 is 3 times -5, -15. You add those, you do get 0. That's good. X plus 5 is a factor. Now, what do we do from here? What do we do with these numbers? Because remember, our goal is to factor the x plus 5 out of this function. So we get x plus 5. But then we're left with something left over that we need to factor again. So what we do is we say, okay, we've done the synthetic division. So after the synthetic division, the numbers down here are the coefficients of our factorization, whatever's left. The result is the coefficients of our factorization. Okay? So we take the 1, the 4, and the 3, and those become the coefficients 1 degree smaller than what we started with, right? Because we factored out this x plus the 5. So this becomes x squared, 1x squared, plus a 4x, plus a 3. All right, factorization covered. So we're not done, because we need to factor this fully, which means we need to see if we can factor x squared plus 4x plus 3. Eventually, you could use synthetic division here and check, can we factor it that way? But we've already done quadratic factoring. We used a method called the Xbox method. So A, we write down A, B, and C from our quadratic. A is 1, B is 4, C is 3. And since A is 1, we don't need the box, we just need the X. We need two numbers that multiply to make A times C, so 1 times 3, which is 3, and add to be B, which is 4. So we need two numbers that multiply to make 3, add to make 4. Those numbers are 1 and 3. Which means this x squared plus 4x plus 3 factors to be x plus 1 times x plus 3. Which means our answer is x plus 5 times x plus 1 times x plus 3. Or some different ordering of that. So you could also have, like x plus 1 first, x plus 3 next, or x plus 5. It doesn't matter what order you write these in. You can even write them in this order. Any one of those is correct. So this, or that. They're all the same. We've just changed the order of the multiplication. Which on the quiz I noticed, and I should have marked those all correct. So if you're looking through your quiz score and it says it's wrong, but you have the full points, it's probably because you wrote it in the wrong order, which is okay. Because there's not a wrong order, it's just the wrong order. All right, and now it's fully factored. So we've factored it until there's nothing available left to be factored. So that's what we're doing today. Taking synthetic division to factor a bigger problem, and then we're going to factor our smaller problems even further. Any questions so far? I think that'll be enough room. Guess we'll see. Okay, always with these, I want you to check if there's a greatest common factor first. So 2x to the 4th plus 6x cubed minus 26x squared minus 30x. And we're going to factor out x minus 3. That's the one they've given us to factor. Now, we can actually factor out the x minus 3 first. We can do synthetic division on this problem and then do factoring after that. But always check if there's a greatest common factor first. We could take it out later, but it's easier to make the numbers smaller and then work with those smaller values. Okay, you don't have to, but it's easier. So here we have a 2 in common everywhere, so I'm going to divide out a 2, but then I'm also going to take out an x. We got x to the 4th, x cubed, x squared, and an x here. So 2x times x cubed is 3x squared minus 13x minus 15. And then they've already told us that x minus 3 is a factor, so we could already write, 2x times x minus 3 times. We don't know what comes next, but we will because we're going to do synthetic division. So we use the opposite. We use positive 3. And then I don't need to use the 2, the 6, the 26, and the 30. We're going to use these numbers from, oh, whoops, I did not mean to write right there, but the 1, the 3, the negative 13, and the negative 15. So 1, 3, negative 13, negative 15. So we're just going to add down and then multiply diagonally. And we should get 0 at the end because they told us it was this is a factor. So 1 times 3 is 3. This makes a 6. Times 3 is 18. 18 minus 13 is 5. 5 times 3 is 15. That does add to be 0. And so then these numbers are the coefficients that go in here. 1x squared, 1 degree less than what we were dividing. 6x and a 5. So we need to factor this quadratic further to fully factor the whole polynomial. But we took out the greatest common factor first because it made our number smaller, and then we factored out the x minus the 3. And we're left with this from the synthetic division. Okay, so we need two numbers that multiply to make 5 and add to make 6. Two numbers that multiply to make 5 and add to make 6 are 1 and 5. I want to say 1 and 6, but that adds to make 7 and multiplies to make 6. That's not right. It's 1 and 5. And now, since a is 1, because this is 1x squared, our answer is going to be 2x times x minus 3 times x plus a 1 times x plus 5. And those should be the same. Or our original problem is the same as this thing factored out. What do I mean since x is x squared? I'm going to be honest, I don't remember saying that, even though I probably did. Oh, I think what I said, Antonio, because it's 1x squared, we're doing this x method with the 1 and the 5 here. We don't need to do the box. So I'll do another problem where this is not 1x squared and it's like 3x squared or something. And we're going to need to use more methods back from November when we were factoring quadratics. I think that's what I was saying. How did I do the blue part? The first blue part here? How did I go from our purple problem to the first blue line? Well, I noticed that each of these can be divided by 2. I can divide 2 by 2, I can divide 6 by 2, I can divide 26 by 2, and I can divide 30 by 2. And so I want to reduce all my numbers so that they're tinier so I can make the problem easier. So I divided them all by 2. I took out the 2. I factored out 2. And then I also saw that every term had an x in it, especially this last term. So I also factored out an x. So then what's left is each of these terms divided by 2x. Well, 2x to the fourth divided by 2x gives me x cubed. 6x cubed divided by 2x gives me 3x squared. Negative 26x squared divided by 2x gives me negative 13x. And the negative 30x divided by the 2x gives me the negative 15. I factored out this greatest common factor. And then I'm left with this blue stuff. The next line, I used the x minus 3 they gave me at the beginning. Said, oh, I know that's still a factor. Yeah, I changed what the problem looked like, but this is still a factor. And so then I factored this using the x minus the 3 and the synthetic division to find this red piece. What's left from this polynomial after I factor out the x minus the 3? Does that answer your question? Yeah. The big thing here is always try to factor out a greatest common factor first because then the problem's easier. just easier. Now I'm not doing synthetic division with 2, 6, negative 26, and negative 30. I'm doing it with 1, 3, negative 13, negative 15. These numbers are smaller and therefore easier to work with. That's all. Greatest common factor just makes it easier. Okay. Let's do another one. Let's do a couple more. X cubed minus 12x squared plus 47x minus 60. So again, they're telling us that this x minus 3 is a factor. And so I can set up my synthetic division using this x minus 3 and then the coefficients from the problem. We're basically dividing this polynomial by this to see what we get left. So I have 1x cubed minus 12x squared plus 47x minus 60. So we're going to add down and then multiply. We're multiplying to get our next addition. So we add the 1 down, multiply that by 3 to get the next addition problem. Negative 12 plus 3 is negative 9. Times 3, negative 27. We get a 20. 20 times 3 is 60. Negative 60 plus 60 is 0. So that's good because that means it is a factor. There's no remainder left over. And so we can rewrite this polynomial as x minus 3 times 1 degree less than x cubed. So 1x squared minus 9x plus 20. So we're just using the numbers that we got from our synthetic division as the coefficients of our new polynomial. And then we need to say, okay, well, we have a quadratic. It's x squared. So the way to factor this thing is a equals 1, b equals negative 9, c equals 20. What two numbers multiply to make 20 and add to make negative 9? Well, I don't actually know. 20 times 1 multiplies to make 20. That doesn't add to make negative 9. 2 times 10. That adds to make 8, or subtracts, and 12, not negative 9. 3 doesn't go into 20 evenly, so 4. 4 times 5. That'll add to make a 9. So the numbers we get are negative 4 and negative 5. They need to add to make negative 9 and multiply to make a positive number. So negative times negative makes a positive. So that means we just use those two numbers. And so we get x minus 3 times x minus 4 times x minus 5. And that is our fully factored polynomial. Any questions there? So I can't quite see the whole problem. Okay. So let's do one where A is not 1. So I'm not sure that there will be one like this on the test. I think we talked about avoiding it because it's just more difficult. But I want to remind you of it anyway, just in case. So we're going to factor x minus 2 out of 3x cubed minus 4x squared minus 9x and plus a 10. Notice this has a 3 at the beginning here. There's not a greatest common factor to take that 3 out. So my assumption is that somewhere at the very end, we're going to have a 3 times an x as part of our answer. Okay? So just like normal, I'm going to do synthetic division with this polynomial into this polynomial. So we use 2 into 3, negative 4, negative 9, and 10. So far nothing's changed. Still all the same. So we're going to add down and multiply to get our next addition problem until we get to the end. And we're going to get 0 because it's a factor. We've already been told it's a factor. So we add the 3 down. We're going to multiply that bottom number by 2. And then we're going to add these two. 6 minus 4 is 2. Multiply 2 times 2, we get 4. 4 minus 9 is negative 5. Negative 5 times 2 is negative 10. And negative 10 plus 10 is 0. So what that means is that we get x minus 2 times 3x 1 degree less is squared plus 2x minus a 5. That would be our polynomial. Now, we have a quadratic that we need to factor. Sometimes these won't be factorable, but we should not assume that it's not factorable. We should check it. So the way to do that is same Xbox method. You say, okay, A is 3, B is 2, C is negative 5. Just like we were doing in November and just like we have been doing. The X is A times C on top and B on the bottom. So 3 times negative 5 is negative 15. And then the bottom is 2. So what are numbers that multiply to make 15 and add to make 2? Well, 5 times 3 is 15. But one of them needs to be negative so that this multiplies to be negative, and negative so that they add to make 2. So it's the 3, because 5 minus 3 gives us the 2. Now, what we've been doing so far is just grabbing those two numbers, and that's our factorization. But think about this. X plus 5 times x minus 3 is not the answer. I crossed it out, but probably too soon. Because this would say that 5 times negative 3 gives me negative 15. That's not negative 5. And then, yes, the 5x and the negative 3x are going to give me the 2x, but this x times x is not going to give me 3x squared. This is not the answer. This was a common problem that we had back when we were just factoring these quadratics. Is like, oh, we did the x part, but then we're just saying this is the answer. This does not multiply back to make our original problem. What we have to do is the box. And the things inside the box add to make the original problem. The 5 and the negative 3 add to make this 2x. So it's 5x and negative 3x. And then the other two squares are just the first term, 3x squared, and the last term, the minus the 5. And so everything in here should add to make what we originally started with. We've got the 3x squared here, and the negative 5 here, and then the 5x and the negative 3x make the 2x. We're just working backwards from the multiplication. And so we want to figure out, well, what multiplies to make these things? Factor out the common numbers. Well, these are both negative, but they don't have any number in common, so it's just going to be a minus a 1. horizontally here, the 5x and the negative 5 both have a 5 in common. I can divide both of those by 5. And then 3x times negative 1 gives me this negative 3x. So this is 3x, which means this just is x. And so what we're saying is this 3x squared plus 2x minus 5 gets factored to be x minus 1 times 3x plus 5. Now, that's not our answer, because that just factored this quadratic. The answer includes the x minus 2. So our final answer is x minus 2 times x minus 1 times 3x plus 5. And that's it. Any questions on anything we did there? Hopefully we're reminded of back to our factoring quadratics back in like November or December, whenever we were doing that. Okay. So let's do another one. Oh, sorry. When x cubed has a coefficient greater than 1, yes, Antonio, either we're going to use the box or there's a greatest common factor. So like not the previous problem, but the one before that, right? This one had 2x to the fourth. And so we factored out a 2x. And so then it didn't have a number here with the x squared. But if you get to the x squared and it's not 1, then you're going to have to use the box. Yeah. Because like we have a 3x here, but you can't divide all this by 3. Right? There's not a greatest common factor. It's factorable, but there's not a greatest common factor. Okay, let's do another one like that. Let's do another one like that. Hold on. 5x cubed. Oh dear. Sorry, I'm trying to save paper. Okay. 5x cubed plus 9x squared minus 26x minus 24. That's 26. I wrote 27 on accident the first time. So no greatest common factor. Can't divide any of those numbers by 5, except for the first one. Can't divide them all by 3. And so we're going to factor out the x plus 3 using synthetic division first. And then whatever we get from there, we'll factor using a different method. So we get 5 and 9, negative 26, and negative 24. And so we're just going to add down, multiply to get our next addition problem. Okay, so 5 here times negative 3, negative 15. It's going to give us negative 6. Multiply, we get positive 18, which means we're going to get a negative 8, because 18 minus 26 is negative 8. Yep. Then multiply 8 times 3 is 24. They're both negative, so we get a positive, and we get a 0 at the end. And so that gives us x plus 3, that's what we factored out, times 5x squared, 1 degree less, but same coefficient, minus 6x, minus an 8. So the coefficients from the numbers from our synthetic division make up the coefficients of our new polynomial after we have factored out the x plus 3. If we were to multiply back, we should get all the stuff we started with. Okay. Then we're going to use our Xbox method. So A, B, and C come from here. A is 5, B is negative 6, C is negative 8. Two numbers that multiply to make negative 40 and add to make negative 6. I don't actually know the factors of negative 40 that add to make negative 6, but let's start with the obvious ones. 40 and 1, not close enough to be 6. 2 and 20, not close enough to be 6. 4 and 10. Those are close enough. So one of them's negative and one of them is positive because they multiply to make a negative and add to be a negative. So the bigger one has to be negative to give us the negative 6. And then we're going to make our box. And so we get a 4x in one, a negative 10x in the other. And then the first and the last boxes come from our original quadratic here, 5x squared and the negative 8. And then we're just going to factor out everything in common. So vertically here we have a negative 2 that we can take out. And if that's negative 2, then this has to be, let's do this one. This one has to be 4. 4 times negative 2 gives us a negative 8. This has to be just x, because x times 4 gives us the 4x. And then that means that this is a 5x. And so 5x squared minus 6x minus 8 factors to be 5x plus 4 times x minus 2. And that means that our final answer is x plus 3 times this stuff, 5x plus 4 times x minus 2. Okay. Now, your homework does not have problems where a does not equal 1, where a is like 2 or 3 or 5. Your homework just has a equals 1 problems. I think we discussed as a team that the test would likely also only have a equals 1 problems. But I want you to see and remember this because it might be the case that they don't. We may give you problems where a does not equal 1. Okay, and so you need to be prepared. I believe that is all the notes I wanted to give you. How much time do we have left? Perfect.